Hi, Assalamualaikum. We are from Group 3, so we are going to present Lab 1, which is ethanol gas diffusion in air. Hi, I'm Shurina. We'll start with abstract. So the experiment aims to study the diffusion coefficient of ethanol in air and also determine the mass transfer rate without convective effects. So apparatus used are a blower, thermometer, test tube, temperature controller, and so on. And this method, we have a tube that should be connected between the blower and also T-tube. The data taken must be recorded for every minutes observed, and the experiment might close with turn off the heater and blower, followed up by switch off the main switch panel. And the result of experimental of DAB equal to 1.35 times 10 power of 3. Since the theoretical shows 1.526 times 10 power of 5 m squared over s closely same as value, so that the percentage error still shows 8745.50%. And the mass transfer rate of ethanol diffusion increase as the change of height increases for every minute taken. So that's all. I will pass to the next presenter. Thank you.
For methodology, firstly, the arsenic water bath tank was filled with tap water until 25 mm below the top of the tank. Secondly, the glass T tube was filled with test liquid by using a pipette till the test liquid level is below 10 water level. Thirdly, the blower to T tube was connected with air tube and telescope was adjusted until it focused at test liquid level. Fourth, the main switch on the panel was switched on after the initial height of the liquid level was recorded. Fifth, heated up the water until it reached the set temperature, which is 70 degrees Celsius after the heater was turned on. Then the blower was switched on to the high airflow and started salt wash. Lastly, the new value for test liquid level in T-tube was read and recorded after 5 minutes. Then we continue with result and calculation.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Anas bin Ahmad Sabaudin, number matric KH20051. So for the experiment, I will present about result. Basically for the experiment is we take 5 readings for every 300 seconds. So what we got from the experiment is LT in mm, which is like I show is 7.05 and so on. So then what we have to calculate change of height, which is delta L. Delta L is LT minus L naught, and then we have to calculate T over delta L in S over mm. So basically this is the full result for the experiment for our group. So this is the calculation for gas diffusion coefficient, which is T. So this is the formula we get from the lab module for the experiment. So what we get from this long equation, which is we can split it to every part, like y equal to mx plus c. So when we get the we done the experiment, basically we have to plot the graph. So what we get from the graph is the gradient m. So we don't have to calculate, we don't have to use this whole equation, but we can use only part for m, which is gradient slope. So we use equation rho L over 2md times CBM over CACT, and we only want to get the D, which is exists in this part, gradient or slope. So final equation for calculate gas diffusion coefficient is D equal to CBM times with rho L divided by CACT times slope and time 2m. So for the experimental, we got the answer 1.35 times exponent 10 over negative 3 m squared over s.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nuri Yasmina binti Bakaruddin, ID number of case 20050. Today I will present to you about discussion. So this is the graph of time over change of height versus change of height. Diffusion is the random motion of molecules driven by thermal energy resulting in molecular movement from areas of high concentration. From the graph, we can observe that as the value of time over change of height increase, the change of height also increase. The gas diffusion coefficient that we obtained from the slope of the graph was 1.35 times 10 power of negative 3. Meanwhile, the theoretical value was 1.5262 times 10 power of negative 5. Between theoretical and experimental value of diffusion coefficient, the percentage error was 8,745.50%. This is due to the error occurred during handling the experiment. That's all from me.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Asna binti Muhammad Nasir and my ID number is KH263. And I will continue for the discussion for question number 4. There are few factors that can increase the mass transfer rate. First is temperature. When the temperature increases, the kinetic energy increases and the movement of the molecules of ethanols will increase, and which will let the mass transfer rate of ethanol diffusion also increases. Next is concentration gradient. When the difference in concentration gradients increases, the ethanol molecules from higher concentration region will have greater force flow from lower concentration region. Last but not least is the type of molecules being used. In this experiment, we used ethanol in liquid form. So I would like to suggest maybe we can use ethanol in gas form, which has higher tendency to diffuse and give higher mass transfer rate. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Shazwina binti Rustan. My ID number is KH20055. I will explain about the conclusion. First of all, this experiment achieved the objective of diffusion coefficient, which the value is 1.35 times to the power of negative 3 with the unit m square per second. For the second, the study of mass transfer rate without convective effects, then known as material transfer between a boundary surface and moving fluid, or between two relatively immiscible moving fluid. Lastly, this experiment explains that the transfer of a chemical from a high concentration area to the low concentration area. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Asna binti Muhammad Nasir and my ID number is KH263. And I will continue for the recommendation part. First is, eyes of the experimenter should be perpendicular to the scale while taking the reading to avoid the parallax error. Second is, time interval should be taken carefully. Last but not least is, avoid ethanol to drop into the tube to make sure the accuracy of the reading. Thank you.